What is the significance of quantum computing in the constantly evolving digital age that we inhabit today? You may have pondered over this question as you sail through the sea of digitalization. Quantum computing, earlier restrained to the universe of science fiction, is now a leading light of technological progression. It has the potential to transform a broad spectrum of industries, from cryptography to material positioning quantum programming, as an essential skill for tomorrow's world. The impact of quantum computing on our future cannot be overstated. It is all set to redefine our understanding of technology and its capabilities. Firstly, Q-hash is a domain-specific language that was developed by Microsoft. Complex quantum operations can be created by developers using Q-hash, which is integrated with the .NET framework. It makes quantum computing more approachable for individuals who are familiar with traditional programming languages by utilizing well-known programming concepts. Next on our list is Qiskit, an open-source framework hailing from the labs of IBM. Qiskit empowers developers to draft quantum algorithms using Python. It offers tools for crafting and manipulating quantum programs, and running them on prototype quantum devices or simulators. It's a fantastic choice for Python enthusiasts ready to dip their toes into quantum programming. The third language is Cirq, a brainchild of Google. Cirq, a Python library, enables writing, manipulating, and optimizing quantum circuits. Its focus on near-term quantum computing makes it a valuable tool for researchers eager to explore the capabilities of noisy intermediate-scale quantum computers, or NISQs. Our fourth entry is Quipper, a quantum programming language embedded in Haskell. This scalable, functional language places a high emphasis on high-level abstraction. It has found its application in implementing a variety of quantum algorithms and protocols, making it an excellent choice for developers who appreciate the elegance of functional programming. Last but not least is Forest, a quantum programming environment developed by Rigetti Computing. Forest includes PyQuil, a Python library for writing quantum programs using Quill. It facilitates rapid prototyping of quantum algorithms, making it a favorite among developers who value speed and efficiency. To sum up, Q-hash, Qiskit, Cirq, Quipper, and Forest are the top quantum programming languages, each with a distinct set of features. Famous for its ability to integrate with conventional languages, Q-hash allows for a more seamless transition into quantum programming. Qiskit is favored for its comprehensive library and open-source nature, encouraging collaboration and continuous improvements. Cirq stands out for its focus on creating circuits, an essential aspect of quantum computing. Quipper is appreciated for its emphasis on scalability, a vital factor in complex computations. Lastly, Forest is known for its hybrid classical quantum approach, demonstrating the tremendous potential in merging these fields. Whether you're an experienced developer or an intrigued beginner, gaining proficiency in any of these languages will empower you to explore and shape the fascinating field of quantum computing.